All right, we're back, and I'm sorry this video has to come to you in two parts. So, what really threw me off in this problem was that negative 3x squared, because I'm trying to wrap my head around a diagram. I'm like, I've got negative 3x squares, but I can't have a negative x squared in my picture. Anyway, we're back. I had to take a moment to struggle a little bit. Yes, even math teachers have to struggle a little bit, but that means my brain grew, right? Okay, here's the thing. I'm going to take that negative out for just a second. As long as I'm keeping the fact that I'm dividing b over 2a, right, because it's my b, my 2a, I'm still going to get that negative 3. Okay, and that negative 3 is still going to be the part inside my parentheses here when I get to expressing my squares. Here's the thing. Yeah, it's negative 3. Okay. I just have to second guessing myself. I can always go back and expand and distribute to check myself after, so you'll watch me do that too. Okay. I'm just going to say I have negative of these. Because then when I start to put my final equation together, here's the thing where I was having a moment. Because have I added in 27 or have I taken out 27? Because if these are all negative squares, like when I distribute this back out, right, I'll have like negative 3x squared minus 6x plus 9. So negative 3x squared plus, 18x minus 27. So really, that's so tiny, I'm so sorry. When I distribute this all back out, I expanded and distributed to see if I could get back to my original standard form of equation. I've really subtracted 27. Because we're calling these all negative squares now. This is why our diagram starts to fail. In the algebra, we need to rely on the algebra, because that's what happened. I got to there and I was like, wait. So, but we're good. We're back on track. But if I subtracted 27, really, when I have to even out the weight of my equation, I have to add 27. So then we get negative 15 plus 27, which will leave us with positive 12. And there we go. If you would like a more streamlined way, I'm going to do this all over again, okay? Another way you can see this is put your extra units off to the side. We're going to deal with those later. Factor out your 3 from your x squared and your 18x and be left with that. And we're going to complete the square here and then put this stuff on the end. Okay, I factored out the negative 3. I've got x squared minus 6x. And then plus, now if I have an x squared and a 6x, it's 3 on each side, still 9 to fill my square. Still plus 9. But we know distribution, right? And so I'm not really adding 9 to my equation, I'm adding negative 3 times 9. So I put in negative 27, so I have to add 27. And there we go. And then this is the whole same procedure. I've got negative 3. This as a perfect square is x minus 3 squared plus 12. And that's a little more clean cut. First, factoring out that negative 3. If this still left you more confused, I have other videos on completing the square where I don't completely blunder. I don't think we have a negative a value on our final exam or our quest. So don't panic. I panicked a little, but I redeemed myself. We're all gonna be okay. I'm gonna keep going on the rest of this. And I'm not redoing this video, I just don't have the time. So I hope you enjoyed that. It's healthy for you to see that other people make mistakes. We all have to struggle sometimes. All right, number 11. Took us long enough to get here. Write the equation of the graphs in each form. Vertex, line of symmetry, facing, stretch number. Okay, you can't see my graph. Okay, I'm gonna start with the vertex form. I think that's one of the easier ways to see things, to write equations for things, because I can look for my vertex. Oh, look, it's right there at -3, 16. Okay. My line of symmetry then, or my axis of symmetry, is x equals -3. I'm facing down. So my stretch has to be negative. My stretch number, when I go over 1, I go down 1. When I go over 2, 1, 2, 1, 2, 3, 4. It looks like I just have a stretch of 1 because I'm not any wider or narrower than a normal parabola. It's -1 stretch, and since I'm flipped upside down, it's -1. Okay. X-intercepts and y-intercepts. Those are coordinate points, so I'm going to write them as coordinate points. My x-intercepts, here and here, -6, 0, and 2, 0. And my y-intercept, 0, 12. Okay, with all that information, that should be enough to at least get one of my forms, and then from there I can convert from one to another. Alrighty. Let's do vertex form, because I know my stretch is negative. I know I've gone 3 to the left, so it's x plus 3 squared, and then I've gone 16 up, positive 16, and that's vertex form. I primarily use my vertex to do that, and my stretch. Okay, standard form. I'm going to expand and distribute from vertex to get to standard. Expand. And now we're going to distribute. I'm going to keep distributing. I'm going to combine like terms. Y equals -x squared minus 6x plus 7 is my final standard form. Okay. And then finally, okay. Add a factor. A times C. -1 times 7 is -7. B on bottom. Multiply to make -7. Add to make -6. -7 and 1. And then we multiply by a, divide by a, which equals -1 in this case. And that's your factored form. Woo! Okay. Number 12. Write this in standard and vertex form. Okay, we've got a factored form. To get to standard form, we're going to just distribute. You can box or FOIL. I like to FOIL. X times x is x squared. Oh, don't forget your y. X times -2 is -2. 14 times x is positive 14x. 14 times -2 is -28. Combine your like terms. That's it. That's standard form. Vertex form. I can't get from vertex from factored form. I'm going to go from standard form to vertex form. And that's going to be with completing the square. Okay. I'm not going to use whatever's on the paper. I need to use this. Okay. Completing the square. 12 divided by 2 squared is 6 squared 36. Okay. So x squared plus 12x plus 36. I had 28, and I'm adding 36 in my equation, so I have to take it away because I don't want to mess up the balance of my equation. Okay. Then I wish I wrote this somewhere else. This is my perfect square. That's x plus 6 squared. These are my extra units. -28 minus 36. -28 minus 30 would be -58 minus another 6 would be 64. If I'm wrong, send me an email and say, Miss Paolini, -36 minus 24 is not that. And send me the right answer, and I'll give you a bonus point on a homework of your choosing. Okay. I think that's it. All right. Last one to go. I can do this. I was really worn out from completing the square one, I gotta be honest with you. All right. And this 12 and 13 is what we took notes on Friday. If you missed it, look on Canvas. I put the notes in the slides. That's so nice of me. And it has all the ways that we move from one form to another, which is really what these last two questions are all about. So 13, we've got vertex form. That's really nice. I'm not going to have to complete the square again. Okay, write in standard form and factored form. Okay, there's no way to get to factored form without going through standard form first, so we have to do that. Get into standard form, expand and distribute. Expand, meaning I know x plus 5 squared is the same thing as x plus 5 times x plus 5. Don't forget that one on the end. Distribute. X times x is x squared. X times 5 is positive 5x. 5 times x is positive 5x. 5 times 5 is 25. Don't forget that minus 1. Combine like terms. Nope. I'm adding my like terms. 5x plus 5 is x, 10x. 25 minus 1, 24. Woo! Last step to get to factored form. Okay, this is your standard. We made it. Because you got an ax squared plus bx plus c. Factored form, diamond method. C is cap, B is bottom. Multiples of 24 that add to 10. I've done this like 3 times already this week. It's 6 and 4. Those two factors keep coming up in my life. Okay. This is it. This is factored form. I love that number 10 felt like a marathon for me, and the rest of this was like, okay, that's not bad. Expand and distribute. Factor, we know that. Alrighty. I hope you feel like you're not running marathon, but if you are, keep going. You are so close to the finish line. I will see you on Tuesday, and we'll have another study day, and then on Thursday, it's quest time. We've got this. Bye.